So in this question, it is given that a particle executes singular harmonic motion in a straight line. First second starting from rest, it travels a distance a. So we know that if in singular harmonic motion, if the particle is at rest, that means the particle should be at its extreme position. So we can just consider that at t is equal to 0, particle is starting from their extreme position and travels a distance a in 1 second. So take it as in a time of 1 second. When time is equal to 1 second, it is moving from here to here, and take it as this distance is nothing but a. And next second a distance b in the same direction, and take it as when time is equal to t second, when t is equal to 2 seconds, let's it reach somewhere over here, and this distance is given as nothing but this distance is given as nothing but b. So we can write overall in a time of 2 seconds it is traveling a distance that is equal to a plus b. Now our aim is to find out the amplitude of SHM is. Let's say the amplitude of the singular harmonic motion is a. So if a particle is starting from mean position, then we'll write the equation for singular harmonic motion as x is equal to a sine omega t. Over here it is not starting from mean position, it is starting from extreme position. So as it is starting from extreme position, its initial phase is 90 or pi by 2. So you can write the general equation as a sine omega t plus pi by 2, or you can write it as this x is equal to a cos omega t is the equation for particle which is starting from extreme position. So over here, just remember one important thing: whenever we are writing this x, that is displacement from mean position, that is not representing the actual displacement of particle, that is displacement from mean position. So if a particle is traveling a distance a from their extreme position, so displacement is not equal to, according to this equation, the displacement is not equal to a. So we should not write a is equal to a cos omega t. We can say that this x is displacement from mean position. So from mean position it is traveling a distance a minus a. Got it? What I'm saying is, if you are considering this one is this displacement as nothing but a, got it, then this displacement from mean position is basically nothing but a minus a. Got it? So for x you should not take it as a, we should take it as nothing but a minus a. So you can write the equation as this a minus a is equal to nothing but a cos omega t, take it as equation number 1. And same as like we can write if it is traveling distance further b, so total it is traveling a distance of a plus b, so its displacement from mean position is x is equal to a minus a plus b, which is equal to nothing but a cos. Now it is taking a time of 2 seconds for this, so we can take it as it is 2 omega t, take it as equation number 2. Now our aim is to find out the value of a, so we can just try to eliminate this term of cos omega t over here. So we can write this a minus a plus b is equal to nothing but, this is in the form of cos 2 theta. We can write cos 2 theta is nothing but 2 cos square theta minus 1. So if you are writing it as this is equal to 2 cos square omega t minus 1, and from the first equation we can put the value of omega cos omega t over here. So we can write as a minus a plus b is equal to nothing but a into 2 into, instead of cos omega t from the first equation we can write it as a minus a divided by a the whole square minus 1. Now if we are solving this, we'll get as a minus a plus b is equal to nothing but a into 2 into, this is a square plus a square minus 2a divided by a square minus 1. So we can write as a minus a plus b is equal to a into, this is 2a square plus 2a square minus 4aa minus a square the whole divided by a square. So we can cancel this a and this term. Now if you are multiplying this a over here, so we will get as it is a square is equal to a minus ab, which is equal to, over here you can observe that this 2a square and 1a square get cancelled, so this is going to be a square plus 2a square minus 4aa, and we can cancel this a square and this a square, so this is going to be 3aa minus ab is equal to 2a square, and if you are taking this a as common over here, which we can take it as nothing but 3a minus b is equal to 2a square, or you can write the value of a is equal to 2a square divided by 3a minus b.